Hey, good day everyone. My name is Joy Leroy. Today I'm going to make a presentation which is about BSC121 calculus assignment. So, for this assignment, I'm going to share about the applications of derivative to economics and how to use Washoe method to find the volume of the solid of revolution, and also the moments and center of mass. So now let us start. The first topic is about the applications of derivative to economics. The derivative in economics is very important for analyzing rate of change, optimization, and also marginal analysis. And it is including cost function and average cost function, revenue function and average revenue function, and also profit function and average profit function. For the cost functions, it is a mathematical formula used to calculate the total cost of production for a given quantity of output. It usually denoted C bracket x, where x is a positive integer. The derivative of cost function gives the marginal cost, which is the rate of change of the total cost with respect to the quantity x. So, let us look at one of the examples. We suppose that the cost function is equal to x squared plus 9x plus 14, where the x squared and 9x is variable cost, while 14 is a fixed cost. So we need to differentiate the cost function equation, and we will get 2x plus 9 for the first derivative of cost function, which is also called marginal cost. If we want to calculate the x is equal to 100, we need to substitute x equal to 100 into the first derivative of cost function equation, and we will get 209 for the answer. From this, we can make a conclusion. The cost of producing the 101st unit is $209. Next, this slide is talk about average cost function. The average cost function is given by this formula, which is the cost function is divided by x. The derivative of average cost function determines where the average cost is minimized. So, if the derivative of average cost function is greater than 0, it means that the average cost is increasing as x increases. However, when the derivative of average cost function is smaller than 0, it means that the average cost is decreasing as x increases. For example, just now our cost function is x squared plus 9x plus 14. So, if we want to find the average cost functions, we substitute the cost function into the formula, and we will get x plus 9 plus 14 over x for the average cost function. So, after we get this average cost function, we need to differentiate it. So we will get 1 minus 14 over x squared. After we found the average cost functions, we need to let it equal to 0 for minimizing average cost. So we can see that 1 minus 14 over x squared equal to 0, and we need to find x. The final answer shows that x is equal to plus minus square root 14. But since production quantity cannot be negative, thus x is equal to positive square root 14. Therefore, the average cost is minimized when x is equal to square root 14. At this production level, the cost per unit is at its lowest. For revenue functions, it is a mathematical formula used to calculate the total income generated by a company from selling X units of a product. It is usually denoted capital R bracket X where X is quantity of products sold. The derivative of revenue function gives the marginal revenue, which is the additional revenue from selling one more unit. So let us proceed to the example of revenue functions. We suppose that the revenue function is equal to 22x minus 7x squared, and we know that 22x is revenue from selling x units at a fixed price of $22 per unit, while negative 7x squared is a reduction in revenue due to increasing costs. So the first step is we need to differentiate the revenue function's equation, and we will get 22 minus 7x for the marginal revenue. If we want to calculate the x equal to 2, so we need to substitute the x is equal to 2 into the first derivative equation, and we will get 8 for the answer. Thus, the revenue of selling the third unit will increase by $8. And now, I will explain about average revenue functions. We can get the average revenue functions from this formula, which is we take the revenue function divided by x. The derivative of average revenue functions analyze trends in pricing and revenue per unit as x increases. A negative derivative of average revenue functions is common when increasing output requires reducing the price to maintain sales. But it can also be zero or positive in specific situations. So, just now our revenue function is equal to 22x minus 7x squared. We can use these revenue functions continue to find the average revenue functions. So we use these revenue functions divided by x, and we will get 22 minus 7x for the average revenue functions. The next step, we need to differentiate it. And the first derivative of average revenue functions is equal to negative 7. Therefore, the average revenue per unit decreases at a constant rate of 7 as production increases. And actually, the price reduction is to encourage high sales in a company. Besides, the applications of derivative in economics also included profit functions. Profit functions is a mathematical formula used to measure of how much profit or loss that a business generates for a given level of sales. Profit functions represent the differences between total revenue and total cost. And the formula to get the profit functions is we need to take the revenue functions minus cost functions. The derivatives of profit functions represents the rate of change of profit with respect to output x. For example, we used the revenue functions and cost function just now. So, the revenue functions is 22x minus 7x squared, while the cost function is x squared plus 9x plus 14. And to get the profit functions, we need to take the revenue functions minus cost function, and we will get 13x minus 8x squared minus 14 for the profit function. And the next step is we need to do the differentiation. So the derivative of the profit functions is equal to 13 minus 16x. The derivative of profit functions can use to find the profit maximizing output. For this, we just need to let the derivative of profit functions equals to 0. And we need to find the value of x. So from these steps, we can see that x is equal to 0.8 units. Lastly, average profit functions. This function is a mathematical formula used to measure the profit earned per unit of a product. And the formula for the average profit functions is given, which is we need to take the profit functions divided by x. The derivative of the average profit functions determines whether the producing more units will increase average profit. For example, just now our profit function is equal to 13x minus 8x squared minus 14. So we let this profit function divided by x and we will get 13 minus 8x minus 14 over x for the average profit functions. After that, we need to do the differentiation. So the derivative of the average profit functions is equal to negative 8 plus 14 over x squared. To find the maximizing average profit, we need to let the derivative of the average profit function equal to 0. So we continue to find the value of x, and we can see that the value of x is equal to positive square root 14 over 8, so it is approximate to 1.32 units. Since the average profit is maximized, so the negative square root 14 over 8 is rejected. Furthermore, the second topic is about how to use the washer method to find the volume of the solid of revolution. So, let us see what is the washer method. A washer method is used to compute the volume of a solid obtained by revolving a region around an axis. It is calculated by subtracting the volume of the inner hole from the outer solid. We can look at the diagram. It is an example of how the solid is revolving around an axis. And the yellow highlighted one is the formula of the washer method to find the volume. For the formula, it means that the volume of a region between fx and gx from A to B is revolving around an axis, where the fx is greater than gx. And here is an example of the question. Find the volume of the solid generated by revolving the region bounded by the curves x squared equals to 4y and y squared equal to 4x about the x-axis. And you can refer to the graph illustrated. The yellow shaded region is the region that we need to find its volume. The curve in blue color is y squared equals to 4x, while the curve in red color is x squared equals to 4y. And you can see that the two curves are revolving around the x-axis from 0 to 4. So suppose that without the graph, we don't know what is the intersection points between the two curves. So for the first step, we need to find the intersection points. We need to analyze the y for the two curves. So for the x squared equals to 4y, y is equal to x squared over 4. And for the y squared equals to 4x, y is equal to positive square root 4x. For this case, we need to reject the y is equal to negative square root 4x because the region is at the first quadrant. After that, x squared over 4 is equal to square root 4x. So we need to find the value of x. And then we square both sides. So x power 4 over 16 is equal to 4x. And we move the 4x to the left side. So x power 4 minus 64x is equal to 0. Then we factorize the x and we will get x is equal to 0 or x cubed is equal to 64. Therefore, the region is bounded between x is equal to 0 and x is equal to 4. After that, the following step is to express and solve the integrand. Since y equal to square root 4x is greater than y equal to x squared over 4 on the interval 0 to 4, so we substitute the square root 4x as the function fx and the y equal to x squared over 4 as the gx. Then a is equal to 0 and b is equal to 4. Then we can start to do the integration. After the integration, the final answer is 96 pi over 5 units cubed. Therefore, the volume of the solid of revolution is 96 pi over 5 units cubed. Now, we come to the last topic, which is about the moments and center of mass. So, what is a moment? A moment is the product of a mass and its distance from a point. And there is a formula for a moment. The formula shows that a moment is the sum of the product of mass and its distance from a point. For the center of mass, it is a point at which it balances perfectly if supported. There is a formula used to find the x-coordinate of the center of mass. We need to take the moment about the y-axis divided by the total masses. Well, for finding the y-coordinate of the center of mass, we need to take the moments about the x-axis divided by the total mass. So now, let us look at one of the examples of the questions about the moments and center of mass. Find the moments and center of mass of the system of objects that have masses 2, 7, and 9 at the points -2 and 4, 4 and -1, and 6 and 3 respectively. So at the first, we need to find the sum of the product of its mass and its distance from a point, and then calculate the total masses. So for the moment about the y-axis is equal to 78, while the moment about the x-axis is 28, and the total mass is 18. So to find the x-coordinate of the center of mass, we need to take the moment about the y-axis divided by the total mass. So the x-coordinate for the center of mass is 13 over 3. And for the y-coordinate of the center of mass, we need to take the moments about the x-axis divided by the total mass. So the y-coordinate of the center of mass is equal to 14 over 9. Thus, the center of mass is located at the coordinate, which x-coordinate is 13 over 3 and y-coordinate is 14 over 9. That's all for my presentation. Thank you for listening.